Hey math kids, today we're going to talk about the vector between 2 points. And we have vector AB. That's the same thing as saying vector B minus vector A, which is going to be B1 minus A1 and B2 minus A2. So basically we just take the second one and we subtract it from the first one. That's how we're going to remember it. Okay, so trying this in a problem. So we have point A, we have point B, and we have point C. And it says find the displacement vector B from O. So B from O, it's kind of like subtraction where you say this, like 2 from 3, and it like feels backwards almost. So this represents the vector OB, and once we know that, we're going to do B minus O, so we kind of switch it again. So 3, 4, minus 0, 0, and so that's going to be just 3, 4. Okay, now we're going to look at B from O, and that's going to be, or we already did that. What am I talking about? B from A. So that is AB. And we swap them once we look at it in this form. So we write down B minus minus, then we write down A, -1, 2. And so this is like a plus sign, 3 plus 1, we get 4, 4 minus 2, we get 2. So vector AB is 4, 2. And then the last one on this part is A from C. So that's CA, and then we do A minus C, A minus minus, and C. -1 minus 4 is -5. This is like a plus sign, so that's a 7, and that's our vector. Okay, next one. P is defined this way. Q, oh wait, these are just 3-dimensional points, okay. And then we want to find OP, PQ, and then the magnitude of PQ. Okay, so OP means P minus the origin. So we write down P, minus minus minus, the origin is just 0, 0, 0. And that's it. PQ, we do it backwards, so we do Q minus P, 1, -1, 3, minus, 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 -3, 1, 2. So this is like a plus sign, so that's 4, that's -2, and that's 1. And then we're done. Now if we want to find the magnitude of this, we do 4 squared plus -2 squared plus 1 squared. That's 16 plus 4 plus 1. That's 21. And so 21 units, or the square root of 21 units. Okay. The next one, AB, which this notation is the same as like this. So it's just like line segment. AB is the diameter of a circle, and C, -1, 2 is the center. Then we talk about B. B is defined as 3, 1, and we want to know BC. and then coordinates of A. Okay, so BC is pretty straightforward. We're just going to do C minus B. So negative 1, 2, minus, minus, 3, 1. We get negative 4, 1. So that's that. Okay, now if we want to find the coordinates of A, we can just go C to A. Which remember is going to be A minus C. And let's define A as x comma y. So we're going to plug in x, y, minus, minus. Then we do C, negative 1, 2. And we end up with x plus 1, y minus 2. Okay. Now, if we draw a picture of what's going on, we have a center, the center to B. So this is C, this is B. And then we know that A is over here. AB was defined as the diameter of the circle. So we found CA right here. We found BC right here. And they are the same thing because they're both radii. And so what we can do is just set this equal to this and come up with a couple equations. So from here, we can come up with the equation x plus 1 equals negative 4. That's just taking like this entire row. And then we can also do y minus 2 is equal to 1. So if we just subtract 1 from both sides, we see that x is equal to negative 5. And if we just add 2 to both sides, we see that y is equal to 3. And so if we put that into a point, because we want the coordinates, that's just negative 5, comma 3. Alright, let's try another one. Okay, so we have this picture where we have A, negative 2, negative 5, 3. We have B, negative 1, negative 2, 3. And then we have C, and we have D. But we don't know what they are. We also have these tick marks, which are congruents. So we know the distance from A to B is the same as the distance from B to C, which is also the same distance from C to D. So what we're going to do is we're going to find vector AB. Once again, we want to find the coordinates of these. So I'll say x, y. Let's see. Let's do A, B, C, and x, y, z, just to make it easier. Okay, so AB, we can do that. So we're going to do B minus A okay, when we do that, this is like a plus sign, this is like a plus sign. So negative 1 plus 2 is 1. 5 minus 2 is 3. And then that goes to 0. Oh, I wrote this down wrong. I wrote this down wrong. So this should have been a 2. Alright, let's fix that. So this is negative 1. Sorry about that. I wrote this down wrong. Transfer that up there. That's what I get. Now, we know that if we want to get to C, it's just the same distance. So we're going in the same direction, it's the same vector, same length, everything like that. So we know that AB is equal to BC. And so if I'm trying to find BC, I can set up A, B, C, minus, 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 negative 1, negative 2, positive 2. And if I simplify that, it's A plus 1, B plus 2, C minus 2. Now, from there, because of this relationship, I can set this equal to 1, 3, negative 1. And so we get A plus 1 equals 1, B plus 2 equals 3, C minus 2 equals negative 1. If I were to subtract 1 over here, A would equal 0. If I would subtract 2 over here, B would equal 1. If I were to add 2 over here, then C would equal 1 as well. And so these correspond to the coordinates right here. So that's going to be 0, 1, 1. Okay, we can go through this process again for CD, because this is also equal to CD. And so if I'm setting up CD, I'm going to get X, Y, Z, and then my C values like that. And that leaves me with the vector X, Y minus 1, Z minus 1. And once again, since these are all equal to each other, we can set them equal to AB, which is 1, 3, negative 1. And we can come up with X equals 1, Y minus 1 equals 3, and Z minus 1 equals negative 1. So when we do that, we see that our X value is just 1. If I add 1 to this side, Y is equal to 4. And then if I add 1 to this side, we see that Z is equal to 0. So those are the coordinates. So we're done with that problem. Okay, so ABCD is parallelogram. And A is defined as this. B is defined as this. And D is defined as this. Find the coordinates of C. We'll just say X, Y, Z for finding that. Okay. Let's draw this. So let's say this is A. This is B. This is C. And this is D. So we want to know C. And if we look at DC and AB, DC and AB, we know those can represent the same vector. And we know they're going to be equal to each other. So if we set up, so we essentially we're saying this. And so AB, we're going to do B minus A. So 2, 0, negative 1, minus, 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 negative 1, 2, 1, just going to leave us with, that's a plus sign, so that's 3, negative 2, negative 2. Now if we set up DC, we're going to say C, which is XYZ, minus, 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 and then D is 3, 1, 4, and there's nothing to simplify there. Now all we need to do is set up these equations. So 3 is equal to x minus 3, negative 2 is equal to y minus 1, and negative 2 is equal to z minus 4. So when we do this, I'm going to add 3, and so 6 is equal to x. I'm going to add 1, so negative 1 is equal to y, and then add 4, and so 2 is equal to z, and so if we just put those in a coordinate, 6, negative 1, or ordered triplet, 2. Okay, and that's it. I just wanted the coordinates of C. Okay, that's everything for this video. If you need additional help, please come to MathLab. Until then, calculate.